welcome to the solutions to the first Core 1 and Core 2 holiday homework. First of all, we're going to look at a couple of Core 1 questions, and then we'll do a Core 2 one. So first of all, we're going to look at a question about quadratic inequalities, and the key thing here is that it says you've got an equation. It's a quadratic equation. K is positive, okay, and equal roots. So the first thing I'm thinking is the equal roots. That's the really big hint. So equal roots good start. That's telling me about the discriminant, and it's telling me that b squared minus 4ac has got to be equal to 0. So that's what equal roots means. And now I'm going to look at my quadratic equation, and I can see that a is equal to k, b is equal to 12, and c is also equal to k. And I'm just going to substitute. So b squared becomes 12 squared minus 4 times k, and that, there we go, let's get rid of that, 4 times k, and all that equals 0. And we'll tidy it up. 144 is equal to 4 minus 4k squared equals 0. And we can rearrange, so we'll have the 144, and that equals 4k squared. Divide through by 4, so half of 144 is 72, and half of that is 36. So 36 equals k squared, and that means that k equals plus or minus 6 when you square root it. Now remember that whenever you square root something, you get two solutions. However, the answer happens to be k is equal to 6, and the reason for that is because of the fact that they tell us it's a positive constant, so it can't be minus 6, and it also says find the value of k in the singular, so just be very careful about that. Be ashamed to lose a mark. Okay, question 2, we're going to do another Core 1 question. Simultaneous equations, and for an extra juicy point, explain how it's linked to Core 2. Well, we've got two things here. We've got a straight line, and we've got a quadratic curve here. And when you solve them simultaneously, you find the intersection. And we're going to do that now. So we start with the first equation, which is x plus y equals 2, and I'm going to rearrange it for y. So y equals 2, take away x, and then we're going to square it, and the reason, actually no, I'm not going to square it up, I'm just going to stick it straight in there. So off we go. So we've got x squared plus 2y, that's 2 minus x is equal to 12, and then we've multiplied all out. 4 minus 2x equals 12, and hopefully you spot that it's a quadratic, and we go for the familiar quadratic form where it equals 0, very important that, and almost there. Minus 2x minus 8 equals 0. And the first thing we're going to do is we're going to try and factorise it. Always try and factorise first, because it's much faster than using the formula, although you can use the formula if you want. And 8 gives us the options of 1 times 8 and 2 times 4, and it's going to be 2 times 4, and it's a negative 4 and a positive 2. So we have x equals negative 2 from this bracket, or x equals positive 4. You might be tempted to stop there, but just remember that we have got another unknown. We've got y to deal with, and we know that x plus y equals 2, so we use that to get our other value. X plus y equals 2, so minus 2 plus y equals 2, which means y must be 4. And over here, x plus y equals 2. And this time it's 4 plus y equals 2, which means that we've got x is equal, my apologies, you can see my brain's not firing on all 4 today, can't you? So y is negative 2. So we've got our 2 pairs of solutions here and the other pair of solutions here. And just to link that further on, if we were dealing with a graph, we'd obviously want to write them as a coordinate, so we'd have minus 2, 4. Over here we'd have 4, minus 2. And those would be the points of intersection. Moving on to core 2. Interesting, we have some strange artifacts on the screen. Let's delete those. Where do they come from? So, first of all, we've got to show that question. So we've got to start with this, and we've got to end with that. And they're fairly predictable, these core 2 ones. Most of them require you to use this identity, not all of them. Sine squared, let's try that again. This is all going so well. Sine squared x plus cos squared x equals 1, and that comes from Pythagoras. Now, we've got a cos and a sine, and we want to make it all into sine, which means we're going to have to substitute for the cos. So we rearrange this for cos squared x. So cos squared x is equal to 1 minus sine squared x. Very straightforward. And now we can substitute. So we've got 5 cos squared x is equal to 3 brackets 1 plus sine x, and that becomes 5 brackets 1 minus sine squared x is equal to 3 plus 3 sine x. Just in case you missed that, what I've done here is I've taken put it in there, I've taken the cos squared x out and switched it, so I've switched the blue for the yellow. And now I'm going to multiply the brackets, so 5 minus 5 sine squared x, and so on. Now I'm going to just make it all equal to 0. Why is that? Well, I can see it's a quadratic equation, and that's just because I'm used to spotting quadratic equations, as you might expect. So we've got 5 sine squared x, and then we've got our plus 3 sine x, we've got a plus 3, a minus 5, and that equals 0. And you can see that's looking very close to what we're aiming for here. So that means that we've got 5 sine squared x plus 3 sine x minus 2 equals 0. And the minus 2 came from these two here. And at this point we can write QED. It has been shown, it has been demonstrated, because that's what they asked us to show. Now, we have a hence bit now, and some more bizarre screen artifacts. It's the first time this has happened to me. Right, we're now going to solve this equation. Well, the hence bit basically means that we can use our answer to the last part. So we know that this thing here is the same as the thing we just wrote down, which was 5 sine squared x plus 3 sine x minus 2 equals 0. And we're going to factorise that, because this is a very clear quadratic there, so you could do a substitution if you wanted. It's got to be a 5 sine x here, and it's got to be a sine x there. And then 2, well, that's only 2 and 1, very, very straightforward. So it's 2 and 1. And it's minus 2 and plus 1, and equals 0. So this bracket here, 5 sine x minus 2 equals 0. That rearranges to sine x is equal to 2/5, and this one here, sine x plus 1 equals 0, which means that sine x is equal to -1. And then we do the inverse sine, so x is equal to the inverse sine of 2/5, and that works out to be 23.58 degrees, and this is in degrees because we can see from the range up here. And then we have here, we've got x is equal to the inverse sine -1, and that means it's equal to -90 degrees. So that's our first bit. Now we're going to remember that there's potentially a lot of solutions here, so we're going to draw a graph. We always draw the graph. If you don't draw a graph, then you're basically asking to forget solutions, really. So here's the graph of sine x. So we've got that, and we've got up there and down there. And I'm also going to put on this bit here because you'll see in a minute. Now, let's do the first one. Sine x is 2/5. So 2/5 is about there. 2/5 is 0.4. So put 0.4 or 2/5 in. And we go across. Let's do it in a different colour. So we go across here. And there are two solutions between 0 and 360. And there's a solution here and a solution here. Well, this is the one we found out. This is the 23 point, and it's one decimal place, isn't it? So 23.6. And this one here is 180 degrees minus 23.6 degrees. And the other one, sine x, is -1, so -1 is down here. Let's put -1 on. -1. And you can see that your calculator has actually given you this number here, -90. But we don't want that, we want the number over here, which is clearly going to be 270. So let's finish off. Our three values are x is equal to 23.6 degrees, x is equal to 180 minus 23.6, which is 156.4, 156.4 degrees, and x also could equal 270 degrees. Those are our solutions. So, hope you've enjoyed it, and I will hopefully send you another problem tomorrow. Have a good one. Bye.